this video, we're going to talk about composition of two functions. So what does that mean? That means that I'm going to take a function in function notation. For example, function notation looks like f of x. And wherever I have an x, usually we plug in a number. But now we're going to plug in a function. We're going to plug in something else with variables in there and evaluate it. And we're going to end up with variables in our answer, not just a number. Now, function notation has two different types of notation. If I had my functions f of x and g of x, I can write function notation the following way. This first way says, this is where I'm looking at, this blue one here. This says f of g of x. This means I take my function f here and I plug in wherever I have an x, my function of g. This one over here on the right hand side says the same thing. This says f of g of x. These two notations mean the same. It means first I take my function g and I plug it in to my function f. I personally like the notation on the left better, so even if they write a problem that looks like this notation on the right hand side, I usually rewrite it because it makes more sense to me to look at what I have on the left. Okay, so I got two examples for you, each with two problems. So we're going to kind of break our way down into this baby steps. So this first, I want to evaluate with using the functions u of x and w of x. I want to find w of u of 2 and u of w of x. So we'll start off with the first one, w of u of 2. This means that I'm going to take my function u, evaluate it at x equals 2, and take my answer and plug it in for w. So it looks something like this. So I'm going to first do my u of 2. I'm going to do it up here. U of 2. So I write my skeleton out. So there's my skeleton for my function u. And in this green box right here, I'm going to plug in a 2 because that's what they tell me to do here. So this gives me 5 times 2, which is 10 minus 4, and 10 minus 4 is 6. Okay, so now because that equals 6, now I want to say I'm going to take 6 and I'm going to plug it into my w function. So my w function says -2. Let me use a different color here, sorry. We'll use green. So my w function is this one. -2 times blank plus 4. And in my blank here, in this green space, I'm going to plug in a 6 because that's what they tell me needs to go in place of my x. So this becomes -12 plus 4, or -8. So overall, my answer to w of u of 2 equals -8. Okay, now I'm going to make this a little bit more difficult. Now I'm going to say we're going to take our function w and we're going to plug it in to my function u. So this is why we do the skeleton. So I'm going to take my skeleton of u, the function that's on the outside. So my skeleton of u says 5 times x minus 4. But where I have an x, I'm now putting in this function w. So this whole part goes right here. So this becomes -2x plus 4. I took my function w, this whole thing, and I plugged it in where my x went in my function u. Now I mathematically figure out, I evaluate. So I'm going to get rid of that. So I distribute. 5 times -2x is -10x. 5 times 4 is 20. And then I bring down this -4. Okay, and then I combine together my like terms. My like terms are 20 and -4. So this becomes -10x plus 16. And this, oops, I forgot my x. And this is my final answer. It's expected that you have variables in your answer because you plugged in something with variables. Okay, let's do the next one. My functions are a little bit harder this time. They look a little harder to me at least. So, but the concept remains the same. So now I'm looking at some different notation here, but remember this says I'm going to first take my function g here, and I'm going to plug in 7. So I'm going to do this up here. So g of 7, I'm going to write out my skeleton. And in this orange space, I'm going to plug in a 7. So this becomes the square root of 7 plus 9, which is 16, which gives me the square root of 4. Now it says I take whatever answer I got and I plug it in to my function f. So f of 4, I plug in my skeleton for my f function. Remember my f function is this one, x squared plus 6. So here's my skeleton, blank squared plus 6. And now I'm going to take this 4 and plug it in here. So I get 4 squared, which is 16, and 16 plus 6 is 22. So f of g of 7 is equal to 22. Now, I want to find f of g of x. Here, let me move this up a little bit so we can work a little nicer. So now, this says I'm going to take my function g and I'm going to plug it in my function f. So my f is the function I make the skeleton of. So my f is blank squared plus 6. But right in this blue space here, I'm going to plug in the whole function g, square root of quantity x plus 9. Now I evaluate. This squared cancels out this square root. So this becomes x plus 9, and I bring down this 6. And now I combine together my like terms. 9 and 6 are my like terms, and 9 plus 6 is 15. So this overall becomes x plus 15. So f of g of x is equal to x plus 15. So I think the best thing that you can remember to do here is to make a skeleton, and it's always of the outside function that you're plugging in the inside function. Make a skeleton of the outside function. Make your parentheses big. I mean, you see when I do this, or like make them a different color so that it really stands out what where you're plugging in and what you're plugging in. That's why I like to make the skeleton. If you have any questions, let me know. I'm happy to help. Good luck.